All right, let's talk about Neptune. When you look at it, you see this beautiful, calm, blue marble hanging out at the edge of the solar system. You'd think, okay, we've got this one figured out. But the truth is, this distant giant is just a world of absolute, mind-bending contradictions.
So let me just ask you a quick question. You've got all the planets lined up, right? Mercury out to Neptune. Which one's the coldest? It's got to be Neptune, doesn't it? I mean, it's the farthest from the sun. It just makes perfect sense.
And nope. Incredibly, it's not. For some reason that still has scientists scratching their heads, Uranus is actually the coldest planet in our solar system. And right there, that's your first clue that Neptune just doesn't play by the rules we expect it to.
Okay, let's try another one. A real simple one. On pretty much any planet, what happens during summer? Things heat up, right? Of course. You're getting more direct sunlight. So during Neptune's summer, which by the way lasts for 40 Earth years, it has to get warmer, doesn't it?
Wrong again. Neptune is the only planet we've ever seen that actually gets colder when its summer side is facing the sun. And all these bizarre little facts, they all point to one thing. We really don't know Neptune at all.
So that calm, peaceful blue image we have of Neptune, it's a total illusion. Because maybe the biggest contradiction of them all is just how unbelievably violent its atmosphere is. I mean, we're talking about a planet with winds so fast, they literally break the sound barrier.
Yeah, you heard that right. The atmosphere on Neptune is just a place of pure, unimaginable violence. These are not just winds, they're supersonic currents whipping around the planet at speeds that are just staggering, way faster than anything we could ever experience here on Earth.
And these winds, they're not just fast for the sake of being fast. They are powerful enough to create weather systems on a scale that is almost impossible for us to even wrap our heads around.
I mean, just look at the scale of this thing. This monster storm system, they called it the Great Dark Spot. It was so enormous that our entire home, planet Earth, could fit comfortably right inside of it. These winds could literally toss our world around like a pebble.
And if you look really closely at the pictures of these storms, you can see these little wispy white clouds floating around them. Here on Earth, those are cirrus clouds made of water ice. But on Neptune, there's something else entirely. They're crystals of frozen methane. They're a constant reminder of just how brutally, unbelievably cold Neptune's upper atmosphere really is.
So, this all leads to the big question, how? How does a planet so incredibly far from the sun, getting so little energy, manage to cook up the most violent weather in the whole solar system? What in the world is powering this mysterious engine?
And that right there, that is the great paradox of Neptune. Logically, the farther you get from the sun, the calmer things should be. Less energy means less weather. But Neptune just throws that whole idea out the window. To get winds this fast, you need a serious heat engine, a big difference between hot and cold. So, where's all the heat coming from?
Well, scientists have two main ideas that they're batting around. The first is basically a supercharged greenhouse effect, where the methane in the atmosphere is just really good at trapping what little heat Neptune gets from the sun. But a lot of people think that's not nearly enough to explain the power we see. The second theory? It's way more dramatic. It suggests Neptune's heat is basically a leftover echo from a ridiculously violent event in its distant past.
And this theory paints an absolutely incredible picture. So let's walk through it. The idea is that Triton, its biggest moon, wasn't always there. It was a stray object from the Kuiper belt that got snagged by Neptune's gravity. But it was going the wrong way, orbiting backward, which created total chaos for Neptune's original moons. They were all thrown off course, spiraling inward and just crashing into the planet, one after another. And all that friction from all those impacts would have superheated Neptune's atmosphere, and that ancient heat could still be powering its storms today.
But see, if Neptune has this super powerful internal furnace, that just leads to another completely baffling contradiction. Its insane seasons. This is where things get even weirder.
So, back in 2005, a 40-year summer started in Neptune's southern hemisphere. Logically, we expected to see temperatures start to climb, but when scientists looked at the infrared data from 2006 all the way to 2020, they found the complete opposite. The planet had actually cooled down by a shocking 8 degrees Celsius.
So, what is going on? There are a few possibilities on the table. One is that the heat is being trapped deep down in the atmosphere, somewhere we can't see it. Another idea is that the methane itself is playing tricks on us, absorbing the infrared light and basically making the heat invisible to our telescopes. Or, a newer theory suggests the sun's energy is actually changing the chemistry up there, turning methane into other gases, like ethane. And that chemical process might be spreading the heat around in a way our instruments just can't pick up, masking any warming that's happening. It's almost like the planet knows how to hide its secrets.
The bottom line is, for a long time, we've kind of ignored Neptune. We've been trying to solve these incredible puzzles from billions of miles away, using tiny scraps of data from a single flyby decades ago. And now, finally, the race is on to go back and get some real answers.
Just think about this for a second. NASA has sent 9 missions to check out Jupiter and 4 to Saturn. But to Neptune, a big, fat 0. Not one single dedicated mission. Pretty much everything we know comes from Voyager 2, which just said a quick hello as it flew by on its way out of the solar system. Neptune wasn't even its main destination.
But that is all about to change. China is planning to launch its Interstellar Express mission sometime in the 2030s, and it includes a probe that's designed to be the first ever to actually drop into Neptune's atmosphere. And in response, NASA is planning its own dedicated Neptune mission for around 2033. Their goal is to study the planet, its internal engine, and its crazy moon, Triton. This isn't just about science anymore. It's a new space race to unlock the secrets of the outer solar system.
Look, at the end of the day, we've pushed the limits of what we can learn from way back here on Earth. The answers to why Neptune gets colder in summer, or what powers its supersonic winds, or what really happened in its violent past, those answers aren't hiding in some old data file. They're waiting for us, out there, in the probes we are finally about to send.
So, as we gear up to finally understand this planet, you have to wonder what other contradictions it's hiding from us. And here's a wild thought to leave you with. Their orbits are strange. So what if, before we even get there, something truly unexpected happens? What if Neptune collides with Pluto? It just goes to show you, out there, anything is possible.